And Lactobacillus pretty much dominates any microorganism when it's applied to that type of product, that ready-to-eat, say, ham product. Its application, which is around 10 to the 6, basically scavenge any substrate and out-challenges a food pathogen. It also has some of its own defenses, which essentially eliminate food pathogens or any other microorganism that might be.
Swine It.
Hello and welcome to the Swine It Podcast. I'm Dr. Tara Donovan, the host of your show today, and today I have as my guest Dr. Darryl D'Souza. Dr. D'Souza is the Executive General Manager of Technical Services for the Sunport Group. Welcome to our show, Dr. D'Souza.
Thanks, Tara, and thanks for having me.
Absolutely. So, Dr. D'Souza, would you take a few minutes and introduce yourself to the group? Just share a brief background of your career path.
Sure. So I'm a meat scientist by trade and got my PhD from the University of Melbourne in Melbourne. Since then, I've had roles as a meat scientist, as a research scientist, and then over the last sort of 20 years, more around managing research and development for Australian Pork Limited, which is the major funder of research in Australia. And then for the last 7.5 years, worked with the Sunport Group. So in terms of my role within Sunport, so I manage the technical services, which entails the R&D, and that's right across the value chain from genetics through to the end product, and a bit of consumer research. I also look after our training, so this is technical training, so certificate in agriculture for pork production as well as pork processing. And so we have our own registered training organization. Benchmarking and decision support. So we use MetaFarms, and we're a distributor of MetaFarms in Australia and New Zealand. And I also manage PIC Australia, which is a franchisee of PIC Global. And we're a closed genetic herd, but we get all our genetic input, if you like, and our technical know-how from the US, even though we can't bring in any genetic material. And then still keeping my meat scientist hat on, I also manage our quality systems for the Sunport Group. So yeah, small role with the Sunport Group.
Well, it doesn't sound like a small role. It sounds like you have a large array of responsibility. So in case some folks don't know, and a little bit for myself, just tell me just a little bit more about the Sunport Group, just the company itself. I understand it's the largest vertically integrated company in Australia. And so just a bit about it.
Sure. So yeah, we're the largest pork producer in Australia. We're vertically integrated right from our genetics to our primary processing, which is our abattoir. Then you've got your secondary processing, boning, and then we also have our value add and further processing where we make, a lot of convenience type products, whether they be heat and eat or ready to eat products like ham and bacon. So the Sunport Group is a privately owned company, 3 Queensland families, the Cameron, Hall, and McLean families. We employ about 1,800 people across the value chain. And it's been in existence for over, I think, 50 years. So long history and, been part of the Australian industry for as long as I've been in the industry.
No, great. I appreciate that.
We have a time and labor-saving product for you. AgriSlats by Healthy Farms is your solution. No more lugging jugs around the barn every month. With AgriSlats, you simply drop the slat through the floor twice a year, and it works to break down solids, reduces crusting and forming. To learn more, visit myhealthyfarms.com.
So, Darryl, one of the areas of expertise is improving and securing food safety. And so in that area, I know you've been working on some projects regarding biocultures and use of lactobacillus in your ready-to-eat pork products. So let's talk about this research area for a bit.
Sure. So, if we look at some of the areas that particularly around what the consumers want, and convenience is very high on their priority when they look for meal solutions. And part of that is, we've seen this huge uplift in Australia with, heat and eat meal solutions, as well as, ready to eat products. So things you can just grab on the go and things like that. So with that comes, we classify ready to eat because there's no heat kill step. They're sort of high risk products. And so we've got to make sure there's no food pathogens, etc., that can make people sick for obvious reasons. And when we look at some of the nasties that we deal with, things like Listeria, Salmonella, E. coli, and then you've got a range of others, but they're the main ones. And Listeria in particular is the one that crops up. Certainly if you look at product recalls in Australia, Listeria tops the list as far as a food pathogen goes in terms of product recalls. And so when we look at the manufacture of these ready-to-eat products, and the biggest volume ready-to-eat product for us is our ham products. So, Christmas, bulk of our hams are produced around the Christmas time, but we'll start production of those, in June, if you like, ready for Christmas. So traditionally, ham products have a very long shelf life. So you've got to maintain product quality across that. But you also don't want any nasties getting in the system. So most ready-to-eat products will have a hurdle step, so something that stops and retards bug growth or eliminates bug growth. And typically we would use a food acid. So most of the food acids that are available are acetic acid based. And we use that just before final packaging. So with ham, there's lots of handling from the raw material through the brining process, the cooking process, and then hams you get full hams, half hams, quarter hams, you get leg steaks, you get a bunch of products from that ham. And so there's a lot of handling involved, and potentially that's where you can have some contaminations happening. Listeria, apart from being a very nasty food pathogen, if you have a Listeria incident, it disrupts your whole production. So you've got to stop production. There's a lot of raw material waste because things that are already in the brine, if you stop production, they have a finite life before they get to be cooked. And so all in all, it can cost you a lot of money, let alone if someone gets sick. And then you have the reputational damage, which in many instances companies do not recover from. So we use an acetic acid based, and more recently, and this is not new technology, biocultures have been in use with food production for many thousand years. But more recently, some of the applications are becoming quite nuanced and quite deliberate in the type of protection that they offer for long shelf life, ready to eat products. And so we've looked at lactobacillus, and lactobacillus pretty much dominates any microorganism when it's applied to that type of product, that ready to eat, say, ham product. And its application, which is around 10 to the 6, will basically scavenge any substrate and out challenges a food pathogen. It also has some of its own defenses, which essentially eliminate food pathogens or any other microorganism that might be. So we've looked at this Lactobacillus, a very particular strain, and we've looked at it from a shelf life point of view. And so about 3 years ago, we did some fairly lengthy shelf life tests. So we're talking in excess of 185 days shelf life. And if you compare it to a food acid, at the end of shelf life, and so in the most instances at the end of shelf life, we've got to add another 10%. So when we do 110% end of shelf life test with the food acid, you might get something, your TVC count will be, say, 10 to the 6, 10 to the 7. And with Lactobacillus, the TVC count was 10 to the 3. So we can certainly get in excess of 220-day shelf life when we use a Lactobacillus bioculture. The first question when you do that, of course, is, now, Lactobacillus, does it actually affect the taste? Does it affect some of the organoleptic properties? And so when we've looked at it, we see no difference in terms of appearance of the product. So there's no additional exudate or slimy feel. There's certainly no taste. So there's no sour taste on account of that Lactobacillus. And there's certainly no impact on some of the eating qualities of the product. So nothing in terms of tenderness, nothing in terms of flavor, etc. So it ticks all the boxes from a shelf life point of view, which leaves then the food pathogen piece. And so we did a challenge study with Listeria, and we looked at a range of different products, ready-to-eat products. So we looked at a quarter ham. So obviously ham being quartered, a lot more handling, a lot more exposed surfaces, a lot more exudate. So if there is any pathogen in there, plenty of substrate for it to grow. We looked at things like ham hocks, traditionally used in soups, or can be shredded and used in sandwiches, etc. And as well as ham steaks. And so we looked at again, the same food acid and this very specific bioculture, Lactobacillus bioculture. And we spiked all the samples with Listeria. The Listeria that we used were strains that we've identified on our site. So they're very specific to one that we found on a product and 2 that were found in environmental swabs. And then monitored them and routinely tested them over 35 days at 7 degrees. And what we found was, so with Listeria culture, what we're looking for as a criteria is whatever application, it doesn't support the growth of the Listeria more than half a log increase. And so we spiked all the test samples with 1,000 CFU of Listeria, and then measured them over 35 days. And we found that the food acid treated samples were able to suppress Listeria for about a fortnight. But after that, the Listeria was able to grow. So it kind of failed that criteria of that half log increase. So it certainly wasn't able to suppress that Listeria growth. When we looked at bioculture with Lactobacillus, we were so pleased in that every one of those products met that criteria, and in some cases dropped Listeria, where rather than just suppress it, it actually had listeria numbers in decline. So again, this lactobacillus quite literally just swamps the product and all the other microorganisms over there and outcompetes, as well as retards their growth. So we were quite pleased with the results, obviously. We're currently working with a number of large retailers, and they're doing their own tests on it, and they're particularly worried about the organoleptic part of it. So they have their own chefs and food technologists tasting the samples, and so far the results very much mirror what we have.
Oh, that's great. Well, I definitely, as a consumer, like ready-to-use products, and they definitely save me some time. So I appreciate all the work that goes into them and the food safety aspect. And 200 days is a long time, so that gives me some comfort. So tell me, how is the lactobacillus applied to the product? So it's not my area of expertise, and so how does it get into the product? What's that application?
So the product comes in a powder form. So the culture comes in a powder form, and then you just put it into solution. And we have a process just before the final pack where it's literally sprayed onto. So a known dose is sprayed onto the product before it goes into the packaging. Sorry. You get new fancy machines, etc., that will blow the packaging bag up and actually spray it in the bag before the product goes in. So you sort of get an even distribution, etc. But keep it simple, I say, and just literally spraying the product. And that way, I mean, the product is reasonably pricey, so you don't want to waste any of it. So just a quick spray on the product suffices, and I think that's the process that we'll certainly go with.
Okay. And you answered my next question was, do you grow it on site in, vats, right, et cetera, or, how does it come? But you said powdered. And so you get it perhaps.
No, the short answer is no. We leave that side of it, and to the actual manufacturers of this lactobacillus. That's not really our core business. One thing more for me to worry about, Tara, that I'd rather not worry about. We just get these frozen as culture packs. We keep them on site, and we just use them as and when we need. One of the things I'd like to do with lactobacillus is within these high risk facilities. I mean, you have people coming through, and yes, you have every precaution around changing clothes, changing boots, wearing gloves, etc. But there's always a risk that people will bring in a food safety pathogen. It's just a given. No system is 100% safety proof, if you like. I would like almost have this lactobacillus be a facility bug, if you like, and have it growing in the drains, in the air conditioning systems and things like that, because as we know, in all these nooks and crannies, that's where we find these food safety bugs. They like to hang out over there, and I'd almost like to have this 24/7 defender, if you like, in our systems, just as a little bit of an extra foolproof. So we're also looking at things like fogging our facilities with this lactobacillus, and so it does float around. It's not harmful to anyone, that's still a work in progress.
Yeah, kind of like an organic disinfectant, I guess, or it's a ubiquitous organism, and if it can be helpful to decrease other bacteria, that's intriguing.
Yeah. Mind you, when you first talk to the managers of those facilities, and they say, "You're gonna do what? You're gonna put bugs all over the place? We're trying to keep these bugs." No, sir, son. It just takes a little bit of a mind shift needed by these guys, but happy to say the guys at Sunpork have really risen to the challenge and adopted this technology, and we're quite looking forward to and hopefully we get the go ahead to use this across all our ready to eat products. So we're just waiting for customer approval before we go down this path. But yeah, fingers crossed.
Yeah, really interesting. Really interesting. I mean, we know that strep and staph is kind of everywhere, but we have some microbiology training. So the general public, right, that's a little bit different concept, or even just a worker, right, that may not be a scientist. So yeah, really, really interesting. So we're going to switch gears just a little bit, because another topic that you and I talked a little bit about was another project that you're working on, or area of study that you and your team are working on, and that's the CO2 stunning process. So tell me about your work there, and maybe a little bit about what led to that work too.
Sure. So let's start with what's CO2 stunning and things like that. Mm-hmm. So essentially, CO2 stunning is a way of rendering the pig unconscious before exsanguination, so before the pig is bled out at the abattoir. Typically, we'll run CO2 concentrations around 90%, and we try to maintain that. We currently run a backloader CO2 system. So this is where the pigs move up an automated raceway, and then in groups of about 7 or 8 animals, depending on size, it's an automatic gate that moves them into the CO2 stunner, and then they're lowered into the CO2. Now, CO2 is pungent, and pigs will respond to that in an aversive way. And in Australia, but you find it all around the world, particularly in Europe, this aversion to CO2 gas has really become front and center. And in Australia, animal activism is on the rise. We have particular groups that will, they get on farm, they get into abattoirs and etc. Anyway, they took some footage of pigs reacting to CO2, and it wasn't a pretty sight. Now, that system was an old system, and wasn't on Sunpork facility, but it was an old system, which is a single entry. So the pigs have to be put into the single raceway. You moved up a raceway, which again has issues, and then into a gondola, which fits about 2 or 3 pigs. And so that has a number of handling issues, which make this whole CO2 issue a lot worse. But needless to say, we have on the ABC, one of our television channels, on the 7:30 report, a lot of this footage was shared, and since then these animal activists have basically got footage from a number of these older type CO2 stun systems, and the consumer land hasn't been very appreciative, and neither has the regulator in some instances where they're asking questions about CO2. If you look at in Europe, there's some big projects. I think the project is called PigStun, and it's essentially a consortium of research facilities and companies in Europe that are looking to find better alternatives or better ways of stunning animals within CO2 systems. And so one of the things we've always looked at, and so if you look at the old system, which is the single entry or the side entry through a single raceway, lots of handling. And so when a pig is stressed before it gets it into the CO2, there's a number of things happen when a pig gets stressed. And, similar to, say, humans, and stress, it changes your respiration rate, your breathing rate and things like that. And all that affects how long it takes for a pig to be rendered unconscious in CO2. And so in pigs, obviously, a stressed pig will take shallower breaths and take longer, and that's the footage. And because it's pungent and pigs have an aversion for that, it's not a very good look for CO2. So one of the projects we're working on is to look at ways within our backloader system, which is an easier handling pigs. The pigs certainly aren't stressed. They move at their own pace. Yes, there's stop people involved, but they're there just in case something happens. And we have things like water sprayers and things behind pigs to get pigs moving, to keep up with our line speed. So at our facility in Queensland, we run about 720 pigs per hour. So it's a reasonable speed, very comparable to what you'd find in the larger packers in the States, North America, as well as in Europe. And so we focused on this handling bit and trying to look at systems whereby the lairage system and how we handle pigs over there, and whether we can improve the handling of those pigs so that when they get into the CO2 system, they're not stressed, or that stress is minimal. And so their breathing and their respiration rate, etc., are not affected. And so they essentially are rendered unconscious quickly. Yes, there's variations, and a lot of how pigs react at the abattoir is defined on their experience on farm. So if you take pigs from say a free range system where they don't see people often when they come to the abattoir, obviously that's highly stressful. It's a novel environment, lots of strange smells and noises and other pigs and people and things like that. So we're trying to look at handling systems at the abattoir. And so it also gives us a chance to look at some new technology. We're looking at particular year tags, so accelerometer tags, to try and gauge how agitated groups of pigs are. And so we've completed the initial baseline assessment of where our pigs are at. And we're also collecting blood samples from these pigs at exsanguination to get also a little bit of a baseline on some of their physiological markers, stress markers. Once we analyze all those samples, we want to look at essentially a training module for people. We have ProHand for abattoirs, and we're looking at what's the optimum level. How many times do stock people at the abattoir need to go through this training? And so we're going to develop a unit within a Cert 3 in pig production, and then see what impact that training does and how that impacts pigs. And so we'll run pigs again past that system once the stock people have had that training, and we'll look at if there is a difference between the basal and to try and get some form of a quantification on what that handling means. I think me personally, I think that handling is really, really important, and it's important from a point of view, no matter whether it's a carbon dioxide stunning system or it's an electrical stunning system. How those pigs are handled will determine how they respond to whatever that stunning is. And so you sort of go, well, electrical stunning, what's the big issue over there? You put them in a raceway. But they again have to be handled, etc. When they get to the point, a lot of them have automated electrode placings and things like that. Very difficult to get a proper stun with electrical electrodes if the pig's thrashing around. And so handling is key to these systems, and that's the approach we've taken. So that research is in progress. The pig stun project in Europe's an interesting one in that they're looking at a range of different aspects with CO2, but also alternatives and other systems. And so whilst that technology will eventually flow to us, we're keeping a very close watch on that project. And they've been quite open about where they're at with their progress, and we're thankful for that. But yeah, that's one area where we need to look at, and for obvious reasons.
Yeah, absolutely. I mean, I have some experience with CO2 just on the farm, right, as a euthanasia tool. And so definitely the tidal volume and the respirations is a big issue when you look at using CO2 on a very small pig, that's weak and not maybe in respiratory distress might be a good example. That's an area of struggle too. So I completely understand that if a stressed pig is hyperventilating, so to speak, or having panting or excited, they're not going to their physiology is going to be completely different than a pig that's having a normal respiratory rate. And so, it's not the CO2 process necessarily that, maybe is the, what was captured on video was perhaps the handling, right? And what was leading up to that point, the pigs weren't necessarily at their peak. So it does definitely. And it really starts with loading from the farm, right, onto the truck, and then the truck, and, and then off the truck. And so there's so many points of handling. I think the one thing that I noticed the very first time I saw a modern CO2 process with mechanical gating and the mechanical gondola, where people really are almost hands off from the pen at the lairage to after the pigs are through the CO2 chamber, was amazing. And I said, we need these kind of gates to load a truck or to even move wean pigs in, because they're so smooth. They just move, the gating moves slowly, and the pigs don't, it's just sort of this automatic process of they have a gate behind them kind of moving slowly, and not a person, not, a person shouting or a person moving, that, everybody's different. So it's a huge area of animal handling that is unexplored, even on the farm, not just at the processing plant.
Yeah, that's a good point, Tara, in terms of, even on farm and euthanizing animals on farm. I mean, we've looked at, and I say we, our veterinarians have looked at a range of things. We've looked at, nitrogen foam, and it's a new technology. Our experience with nitrogen foam hasn't been the best, and there's that excitation phase just seems to be a lot longer, and so CO2 is quite important for us, whether it be on farm or at the abattoir. But equally, in the case of, we get a disease like ASF, heaven forbid we get that. But when you've got to do mass euthanasia, we can't go around shooting animals. I mean, it's not so easy, and it's not good for the people. doing it, etc. So CO2 plays quite an important role in that area as well. And I know our vets are looking at projects using CO2. So CO2 is really important within our system right across. We need to do everything to protect our use to be able to, because provided your animals are handled properly, it's still, in my opinion, the best system to render an animal unconscious.
Yeah, it's definitely a tool we want to keep, and but that doesn't mean we don't continue learning about perfecting it, right? And about what goes into the whole process before the use of CO2. And yeah, definitely, I kind of separate the mass euthanasia emergency management processes can be a bit different than what we might use every day at the plant or the farm, but we still have to continue to look at technologies in both areas, and that's a big quest, right? Definitely. So, well, really interesting. I want to circle back around one more time on maybe a more, let's say, fun subject or probably dear to your heart in terms of meat quality. And so, the fruits of all the labor, right? The meat at the end. So tell us what you're working on in that area.
We have our payment system, if you like, in Australia is based on back fat and as well as weight. So as a consequence, we have very lean pigs. Whether you compare our pigs to North American production or European production, our pigs are very lean, and as a consequence, we have a few issues that we have to deal with, and we also have entire male pig production. So we stopped surgical castration in the late 80s, early 90s, mainly because our slaughter weights were so low. We didn't think the boars would mature enough to produce boar taint, and so that legacy essentially is where we find ourselves, where we've got really lean pork, and one of the issues that we've had to deal with is not so much the boar taint issue, given the male, because all our pigs are immunologically castrated using the boar taint vaccine, certainly for sun pork, but the pig is relatively lean compared to a surgical castrate. And so we're seeing variability in our pork quality and things that we would have taken for granted. So aging of pork would improve tenderness. We're finding that that's not a given. And we believe that's related to how lean our animals are. So we get really good eating experience in some pigs, and in some pigs, obviously, particularly tenderness is really affected. And so we've embarked on a number of projects. A lot of these projects are with the University of Melbourne, through Professor Robin Warner and Professor Frank Dunshea and their PhD students. And there's a PhD student, Michelle Lemaster, who's working and looking at fiber types. And we believe in this selection for leanness. We've imposed a significant shift in fiber type, and Michelle's results certainly confirm that. In a nutshell, that's an area of focus that we need to look at. As a consequence of some of those results, we're still waiting on a whole range of others. So we've got a genomic project looking at what those potential fiber type impacts can be or are happening. So we've looked at characterizing all our lines, both maternal and sire lines within PIC. And our ultimate goal, if you like, is to have a tenderness selection within our our selection criteria, and so we're working towards that. But yeah, that's in a nutshell our meat quality focus. I think I've summed up about 4 projects worth in about 3 minutes or something. But
Yeah.
hope the guys don't mind, because fiber typing is not easy to do, but some of the results we're getting are very insightful, and for us, commercial companies, we're very glad we have these results, and we'll certainly look to do something to change some of those within our systems.
So just at first, when you started to talk about fiber types, I automatically went to, feedstuff fiber, right? Because there's a lot of talk about fiber in diets, right? Changing types of fiber, plant-based fiber. So you're talking about the fiber types of muscle.
Muscle fiber.
Right? Yes. And so muscle physiology. And so, and again, just to, for the rest of our listeners that might be like me, the different, it's essentially the tenderness of the meat, right? And the different fiber types. Tell us just give us a real bird's eye view of that muscle physiology.
So with, there's essentially 3 types. There's some name changes, but you've got your oxidative, your muscle fiber type 1. So these are your redder muscles, high oxidative capacity. They're slow twitch. So these are used for aerobic exercise. Long use. A classic one is your masseter muscles, some of the leg muscles, etc. Then you have your fiber 2A and fiber 2B. And 2B essentially is your glycolytic fast twitch fibers. Doesn't take much before they go into anaerobic, build up lactic acid, etc. And so we're finding a shift from almost 2A, which is a fast twitch oxidative muscle fiber, to a fast twitch glycolytic. And some of the work that Michelle's seen, or some of the results that Michelle's seen, is shows quite a sizable shift in those fiber types. And so that's a consequence of selection for leanness. But there's certain things that come with that, and part of that is it doesn't age, it doesn't break down the same way as some of the other muscle fibers do. And so we've got to look at how we negate that. And yes, we can do a number of things, and one of which is we actually start selecting for tenderness within our systems. It takes time, but with genomics and things like that, that makes the process a lot quicker.
Is there a correlation between that change in selection for the fiber type and the stress? We were talking about the stress of the pig, and in animal handling, and moving into the processing plant, et cetera. Is there a correlation? Have we selected for maybe a different muscle type or response to that stress?
So if you look at the classic, or the best relationship between those two, is in certain breeds, like the Pietrin breed. So the Pietrin breeds are a very muscular, good conformation, but it had a high incidence of the halothane gene, and obviously they didn't respond to stress very well, and even the heterozygotes that had the halothane gene, they still responded to, or weren't very good responders to stress. And so whilst most of our lines don't have that halothane gene, right, I think that relationship can exist if you do have that halothane gene. So Yeah, I think that relationship is still there. Whether it's there when in the absence of the halothane gene, that's not so clear cut. Um, Certainly for a proportion of the herd, um, you'll have, on a percentage basis, you'll have, say, maybe 70% of that herd will have eating quality or objective tenderness that would be in the tender category. But you'll have 30% of those animals that potentially will be, okay, that meat's pretty tough. And so that's the bit we're focused on. And maybe that is a lingering effect of that relationship when we did bring in Pietrin animals into our genetic lines. And this is worldwide.
Yeah.
Most people have actually bred out the halothane gene.
Right.
Yeah.
Right. Which I think the industry, that was done even before, right when I was, graduating from school. So, but you still see some pigs when you're on farm and you're in the plant that, we stress out, so to speak, right? They have a
Correct.
response where, they're clearly have a lactic acid buildup and an issue. And so just wondering in terms of looking at the tenderness if there's a correlation. So, I know that the industry got the halothane gene targeted and bred out, but especially with new molecular techniques in terms of genomics, I think it'll be really interesting to see how we can make progress on meat quality in that aspect.
I mean, the other one, which is more a feed related, so whilst ractopamine was really good for an industry like Australia, it helped us, certainly shift the lean to fat ratio. Didn't necessarily reduce the fat depth, but certainly improve the lean to fat ratio. We can't use that anymore. Not because it's illegal, it's just the retailers don't want us to use any of those types of additives. Australia previously also used to use PST, porcine somatotrophin. So those things also contributed potentially to some of the toughness issues that we had seen, and also some of the aging effects or the lack of aging effects. But now with those over there, again, that's one more thing removed. Certainly within our production system.
Yeah, and I think that's the case in the U.S. as well, is my understanding. So we're concluding our time together. Again, I have Dr. Darryl D'Souza with the Sunport Group. If you have comments or questions for our podcast show or our guest, please send us a message. And if you like listening to our show, give us a thumbs up on your podcast platform as you're listening. Dr. D'Souza, before we sign off, I want you to, we have a few minutes left. Will you share with us some final thoughts or take-homes from our conversations? I know we covered kind of 3 big topics. And like you said, with years and years of research that go into them, but, this is your time to send a message to the industry on kind of a sum up.
Sure. So with food safety, I think food safety is something that consumers take as a given, and it's the easiest way to erode consumer confidence. And new technologies, and I say new, although we've had them for quite a few years, things like biocultures, like Lactobacillus, I think we will see use. More and more use of these types of products. In terms of CO2 stunning, I think the key currently within the current systems, particularly the group-wide systems, is how that animal is presented at the point of CO2, and a less stressed pig will have a better response to CO2 than a stressed pig. And as an industry, and the welfare of the pig, and the way, we've got to give the pig a good life as well as a good death. And that handling is critical and key if we are going to have a best practice carbon dioxide stunning system. And then in terms of meat quality, fiber type, we're starting to see a little bit more, certainly in Australia. Much more work to be done, but some very defined pathways for us to make sure we get over some of those issues that we have currently as a consequence of lean pork.
Very good. That was great.
It's time for our famous three. Feed flow is changing the way the swine industry sees feed. As the world's only on-pipe feed sensor, feed flow tells you exactly how much feed is being delivered to your animals, so you can be sure that every pig in your barn is well fed and growing. With industry-leading precision and up-to-the-minute real-time data and alerts, feed flow is a simple and affordable way to improve production outcomes across your organization. Feed is too expensive to ignore. Try feed flow today.
Now, to end our show, we always ask our guests a few questions just to get to know them a little bit better, and also to give all of us out there some more ideas for books and things that we can do to learn more about pig production, or in your case, food safety. So the first one is, what is your favorite book or resource that you use in your area of expertise? So in the meat science world.
I think people from a meat scientist background or meat science background will get this, but the porcine myology book, I think it's from the University of Nebraska-Lincoln. I've got a hard copy of it. I dare not show it to you. It's got pages with sticky tape all over it. And yes, now it's online, but it's a resource that I constantly visit. And certainly when I'm talking to students and things like that, that book is never too far away from me.
Aha. Well, I don't know if you know this, but I did my undergraduate at University of Nebraska and in animal science. And so the meats lab was, just across the hall. And actually, my sister worked there and got to taste test meat all the time and was, a person that filled out the checklist. So way, way back in my undergraduate days. So very interesting. Yes, I would recall a lot of the professors, I'm sure, that wrote that book.
It's an amazing resource for a meat scientist, and I just love it.
Yeah, no, they have a meat science lab that's great. Yep, I recall. So how about your favorite book or resource outside your area of expertise when you're not, reading about muscle physiology? Share with us where you go.
All right, so I'm reading a book at the moment. It's not necessarily my favorite, but it's just the one I'm reading at the moment. It's called Dear Dad. And it's compiled by a comedian called Samuel Johnson. Samuel Johnson is an Australian comedian, and his sister passed away from cancer. And so he's written to or contacted a whole range of celebrities and famous people and asked them to pen a letter to their father or their dad figure, if you like. And it's just a series or a collection of these letters that people, whether they're famous, celebrities, etc. And it's quite an emotional read. People really open up. And it's also quite funny. There's some letters where kids are writing to their dad asking for handyman tips, and whereas others are quite in depth in terms of what their parents have meant to them and things like that. So just reading. And this book was written or compiled to raise funds for a cancer charity. So that's what I'm reading, and it's quite an illuminating and quite an interesting read.
That sounds interesting. And I think everybody's take on that book might be a little bit different depending on where they are in their life, perhaps, right? And so really intriguing. I like that idea.
Yeah, it's pretty neat.
Great. Well, the last one is for you to share with us an attribute or characteristic that you feel sets successful professionals apart from others. So what kind of quality do you look for?
At the moment, I think a quality like resilience comes to mind. We live in interesting times, and we're confronted by a range of different things, and resilience is something that really helps. It certainly helped me in my career, and I think it's a quality that I think I wish a lot more people had, and unfortunately you see some of the consequences of where resilience isn't perhaps where it needs to be, and it's not a good sight.
Yeah, I think that in agriculture, with given our challenges and even through to meat production, food production, right? Resilience is probably one of the top qualities that many of us have to have in order to stay in this tough industry. So yeah, I agree.
To survive.
To survive, exactly. Well, wonderful. Thank you so much for your time. It's been great. I've learned a lot about what you were working on, and definitely stimulated some thought for me in areas that I didn't really know much about. So have a great rest of your day, and thank you so much.
No, thank you. Thanks for having me.